Let us see the mesh analysis with AC source. So with respect to the electrical circuit analysis subject. So whenever we have a AC source and how to apply a mesh analysis for that. Let us take a simple circuit and we'll try to identify, try to solve that. So let us take the network first. So this is my AC source. Let me give the values for this. It is 100 at an angle 45. So whenever there is AC source, there will be angle. If it is not given, we assume that it is angle is 0. Okay, and this is a 5 ohm resistor, and this is also a 5 ohm resistor, and this is my 20 ohm resistor, and I have an inductor which is given as 20 ohms. 20 ohms. So that will say whenever we have an inductor or capacitor, so this will be indicated as, in the inductor value will be indicated as J20. J20. If it is an inductor, they will, okay, inductor. If it is a capacitor, it will be minus J with respect to the value that. Let us take a 10. If it is a capacitor, it will be given as a minus J. Inductor will be plus J. Okay. So let us see how to apply KVL for this and how to find the voltages here. Let me take what you are supposed to find. Let me give the nodes here: A, B, C, D, E and F. So let us find the voltage at terminal B and D. Voltage, that is V, B, E. So this is what we need to determine. Let us assume this is what we need to find. So let us see how to apply KVL for this. Applying KVL for loop 1. So loop 1 is nothing but A, node A to B, B to E, E to F, F to A. Okay. So I will be writing, so where the voltage source is given 100 at an angle 45 equal to 5 into I1, because the current flowing here I am assuming it as a I1 and here I will assume as a I2. The direction of current can be assumed anything if it is not given. If it is given, you need to consider that direction and you need to find that. Okay, I assume the direction of current, loop current I1, I2 in a clockwise. So the 5 ohm resistor where the current I1 will be flowing. So next comes here, this part of the circuit. So if you look at this, in this branch both I1 and I2 are flowing, whereas I1, when I am taking a loop equation for I1 will be positive, I2 will be negative. When I am writing a loop equation for loop 2, so I2 will be positive, I1 will be negative. That is how we will be considering. So I will write the equation now. So it is plus 5 into I1, that is for the resistor, this one 5 into I1 plus J 20 into I1. So I have taken both with respect to loop 1, which is positive. Now there is a current I2 is also acting, which I need to take as a minus. Minus 5 I1 minus J 20 I1. So this is a, sorry, this I2, not I1, both are I2. So because the loop current I2 is coming opposite to that, it will be taken as a negative. So if I simplify, I can read this equation as 100 at an angle 45, taking common values here, I will take I1 common. If I take I1 common, so look at here I1, it is 5, 5, 10 So that is 10 ohms plus, with respect to imaginary, have 20 j 20. This is my I1. Similarly, when you go plus I2, so I2, if I take, I have I2 over here and I have I2 over here, both are minus, so hence I need to take minus here, I can't take plus, it will be minus. So it is, first I will write the coefficient I2 into 5, because it is a minus, 5 plus j 20, that is minus 5 minus 20j. So this is my equation. Let me take this as equation number 1 from the loop 1. Similarly, for KVL for loop 2. For loop 2, if you go loop 2 here, I have 20 ohm resistor as well as this 5 ohms and 20 ohm in series. So write the equation for that. It will be 20 into I2 plus j into 20 I2. Now because I2 is positive there, because we are considering the loop 2, plus j 5 into I2. So there is a current I1 is also acting. Now I2 is opposite direction, hence I will take minus j 20 I1 minus j 20, sorry, minus, so this is not j, it is a real term because it is a register, minus 5 I1. So there are the second loop, I2 is positive, I1 is negative. In the first loop, I1 was positive, I2 was negative for the branch between B and D. So because it is a common branch for the both the loop. If I simplify this equation, I will get the coefficients of I1 is equal to 5 plus j 20, and I2 coefficient will be plus I2 into 25 plus j 20 equal to 0. So this is also equal to 0 here. This is my equal to 0. So this is my equation number 2. So I have two equations now. So I can solve this equation in the calc, but due to the complex equation is present, I can solve using a calc in an unknown mode, because there are two unknowns, I1 and I2. So I1, I2 are unknown, but it is in a complex form. So unknowns and complex together we cannot solve in the calc. For that reason, we need to go with a normal method to determine the I1, I2, that is by Cramer's rule. By Cramer's. So in this Cramer's rule, we write first determinant for the given equation. There are two equations. I will write a matrix for that. So this matrix will be with respect to I1, I2 and equating to that equation. So I am taking I1 as a first coefficient, I2 as a second coefficient. So in the first equation, what is the coefficient of I1? If you look at that, 10 plus j 20. So this one, 10 plus j 20. So I will take some other color to just highlight that. 10 plus j 20. And I2 coefficient in the second equation is minus 5 minus j 20. Minus 5 minus j 20. Minus 5 minus j 20. Right? And it is equal to that is 100 at angle 45. 100 at angle 45. 100 at angle 45. Similarly, the second equation, if you observe here, I1, I2 coefficient, it is minus 5 minus j 20, right? And I2 coefficient is 25 plus j 20. So these are the coefficient, and equal to it is 0. Equal to it is 0. So this is how we obtain a matrix from equation 1 and 2. So now I will get a determinant of this matrix, this matrix. Let me take the determinant which will be indicated as a delta. So that is equal to 10 plus J20 minus 5 minus J20 minus 5 minus J. I am just rewriting that matrix over there. 25 plus J20. If I take a determinant of this, so I need to multiply this into this. It will be 10 plus J20 into 25 plus J20 minus this into this. That will be minus 5 minus J20 minus, so into minus 5 minus J20. If you simplify this, now you can use your calci. You can go to the complex mode, you can multiply directly this. Using your calci, go to the complex mode and solve directly. You will get the determinant of this matrix as 225 plus J 500. 225 plus J 500. So this is how we get a delta. So now I want to find the current in the branch or voltage in the branch, that is VB. As per the question, we need to find the voltage VBE. So for that, both current are acting, I1 and I2. Hence I need to find current I1 and I2 both. So for that, if you want to determine current I1, then I will take a delta 1. If you want to find a current I2, I will take a delta 2. So delta 1 matrix will be in this fashion. I will replace the first column of this matrix. If you look at here, I will replace the first column of the matrix for determining delta 1. For determining delta 2, I will replace the second column of the matrix. So what I should replace? I will replace the first column of the matrix with respect to these values. So this will come here for delta 1. I will write the delta 1 now. That is 100 at an angle 45 and 0, first column. Second column I written as it is, minus 5 minus J 20, 25 plus J 20. So once again finding the same determinant. So this into this minus this into this. Anyhow it will become 0. So only this into this you are supposed to do. You get answer as 353.55 plus J 3181.9. So this is a delta 1. Similarly, we find delta 2, now replacing the second column of the matrix. So first column we will retain as it is, that is we will retain, that is 10 plus J20, 10 plus J20 minus 5 minus J20. The second column will replace with that is 100 at an angle 45 and this is 0. Once again, if you multiply this into this is 0, this into this is 0, this into minus this into this, you will get the answer in terms of minus. It will be equal to, if you simplify this in a calci in a complex mode, get 1060.66 plus J 176.176.7.76. So once I know delta 1, delta 2, I can determine the current I1. So I1 can be determined using delta 1 by delta, and current I2 can be determined by delta 2 by delta. This is how we determine the current using the Cramer's rule. Okay. So once you simplify this, substituting delta 1 and delta, so we will get I1 as 5.839 at an angle of 17.88. Similarly, we get I2 as 3.759 at an angle of 55.19 amps. So unit is important, it is a current. Okay, delta is not any of current or voltage, hence I have not written unit over there. So these are the unit. Once I know the current I1, I2, now I can determine the current through the branch BE. The current through the branch BE is equal to current in the branch B is equal to I1 minus I2. So once I know this, if you substitute, you simplify, you will get as 3.41 minus J 1.2936. So this is my I1 minus I2. So this term will be my, and in the problem it is given that Z is given, ZB is given, so ZB is given, that is R plus J XL is given. So where R is, if you look at the diagram here, R is 5 ohms and XL is 20 ohms. I will write that R is 5 ohms, XL is 20 ohms. So I need to find the voltage here now, voltage across VBE, that is equal to the current in the branch, that is IBE. So this is my current in the branch IBE into ZBE, that will be equal to, if you simplify, substitute that, we get 75.187 at an angle of 55.189. So this will be the voltage in that branch. So this is how you are supposed to solve whenever we have a AC source, mesh analysis with a AC source using Cramer's rule. Thank you.